welcome everyone to the first event in the Philosophy Speaker Series for this academic year. Our speaker today is Kareem Khalifa from UCLA, who's going to be talking about understanding and measurement, the case of segregation indices. Please join me in welcoming our speaker.
Thank you. Thank you. I just want to begin, first of all, by saying I've had a lovely day here at Merced, and particularly to thank Dan, who I know is a first-time chair and took out an extraordinarily large chunk of his day today to just sort of be an incredible host. And I'm very excited to talk with you all about the work I'm doing. So the way I just sort of describe this talk is it's kind of a Reese's talk, in the sense that there are two really cool things that I'm going to try and put together, and I'm not quite sure that it works off. So in the last 20 years or so, there's been a lot of excitement in the philosophy of science, both about understanding, which is mostly what I've been working on, and then also about measurement. And the two really haven't been in conversation with each other very much. But when you think about it, when scientists have new ways of measuring things, it's sort of a new window into a phenomenon, and it's a really important way of understanding things. So what I'm going to try to do today is sort of advertise, right, the Reese's Peanut Butter Cup, right? That when you take the chocolate of understanding and the peanut butter of measurement, you get something delicious, right, is roughly the idea. And in particular, what I'm going to do is I'm going to sort of motivate this by pitching a particular problem that pops up in the understanding literature. And basically the question is this, which is, does scientific understanding of a phenomenon require an explanation of the phenomenon? And measurement seems like a really good test case for this, because it seems like you can sort of know how to measure something without being able to explain that thing. And I'm a big fan of explanation, for those of you who don't know. So I want to answer that question that I started with: does understanding require explanation? With an enthusiastic yes, if I can. So what I want to try to do is show you how this is like an interesting puzzle for folks like me, who like explanation to be sort of part of understanding. And show you that I think I have at least the sketch of a promising answer of how understanding of an explanatory sort of stripe can be reconciled with the understanding you get from measurement. So that's sort of the goal. Here's sort of the plan of attack, assuming my clicker works. All right, here's the plan of attack. So I'll start off by setting the stage. And essentially, the goal of that by the end of section 1 is basically to suggest there's an account of explanatory understanding, namely mine, that can set up what I'll call 4 handshakes between measurement and understanding. That basically there's sort of some natural ways that we can think of understanding as improving measurement, and you can make sense of these on an explanatory account of understanding. So there are 4 handshakes, but I'm only going to go through 3 of them, and those are sections 2 through 4. Time will not permit me to go through section 5. I'll just say that now. Okay, so with that, here's how I want to set the stage. I first of all want to just tell you a little bit more about this debate about understanding. Then I'll give you an example from segregation research where it looks like we're getting better understanding from better measurements of the phenomenon. And then finally, I'll sort of set the problem space by giving you a few details about my account of understanding. So the debate about understanding, right? There's lots of debates about understanding. The one, as I said, I'm going to focus on is essentially this, right? Does scientific understanding of a phenomenon require an explanation of that phenomenon? Right? So just to give you some intuition pumps, think about, for example, how Newton came to understand the behavior of the tides or the orbits of the planets or what have you, cannonballs like you learned in Intro to Physics, right? He's got an explanation for all those things, right? It's all basically gravitational forces at play, right? And these sorts of examples are the ones that tend to captivate folks in my camp when we talk about understanding, right? And they're often the staples that people use. Measurement has largely been ignored because we focus on like theories and high-level models and explanatory hypotheses and other kinds of hypotheses, and we take for granted, right, that the phenomenon that we're seeking to understand has already been properly measured. And that's sort of been, I think, where the gap or the lack of handshakes has sort of arisen from. But there's an interesting thing about this debate that I want to flag right now that really didn't sort of strike me until I was actually working on this particular project, which is not only is there sort of a doctrinal difference between people who say scientific understanding requires an explanation and those who deny that, right? But there's also an interesting methodological difference that sort of struck me as I was going through this literature. And here's sort of like a very crass way of putting it, just to give you the big picture, and then I'll talk through a little bit of the details. Right? The people who tend to answer yes sort of come more from the philosophy of science side of things, and the people who tend to answer no come more from the epistemology side of things. And that ends up meaning that there are sort of different criteria of adequacy for what counts as a good philosophical account of understanding. Right? So I come more from the philosophy of science side. My methodological criteria tend to be like, how well does this make sense of the science? Right? Whereas when I talk to my friends who think that understanding doesn't require explanation, they're coming more from the epistemology side, and they have like sort of more of a traditional analytic philosopher kind of approach to things, right? What they're trying to do is sort of say like, okay, well, when is it sort of right or intuitive to say that Dan understands what causes peptic ulcers or something like that, right? Right. And so this, of course, just leads to a potential for just sort of talking past each other, right? Because there might be an account of understanding that's really good about making sense of scientific practice, right? But not so good about making sense of when it's sort of natural to attribute understanding of someone given the norms of English, right? Right. And just to sort of make this concrete, suppose that we wanted to make sense of the understanding of how species evolve, right? So what I might do is I might actually sort of go through the pages of The Origin of Species and sort of think about the different hypotheses that Darwin was entertaining, think about what he said about the Galapagos finches and about the fossil record and so on and so forth. And that's going to be what drives me, right? And these are all cartoons, just so these are caricatures of the view. But so like this would be sort of what I think is going on the other side. And I'm happy to sort of talk through examples. The sort of litmus test for this, if you guys want to know, is there's an interesting thought experiment by Galileo where it's really striking how philosophers of science respond to it in one way and epistemologists respond to it in another way. And it tracks perfectly with who will say yes and who will say no to this. I can talk through that in Q&A, but I won't bore you with the details for now. Right? So here's why I think measurement is a really interesting case. Right? There's a slew of really great work in the philosophy of science about measurement. And they're using a philosophy of science methodology. They're trying to make sense of the details of scientific practice, just like we folks in the explanatory camp have been trying to make sense of scientific practice. Right? Obviously, their case studies are slightly different. They're working on measurement. But on top of that, I sort of have already given you a little bit of the intuition pump behind this. Right? On the face of it, right, like sort of if you're just doing a quick flyover, your thought is, well, measurement doesn't seem to be the kind of thing that requires explanation. Right? And it's this that I want to sort of explore in the talk. So what I want to do is sort of just first of all give you a sense of why you might think that measurement doesn't require explanation. I'm going to sort of give you a couple different passes of this to motivate the intuition before I knock it down in the rest of the talk. So if you look through all the great work in the philosophy of science on measurement, like you just don't see people saying that explanation is required to, say, calibrate a measuring instrument. Right? You don't see a lot of explicit denials of it, but I found one from arguably my favorite philosopher of measurement, Iran Tal, and arguably my favorite essay on measurement, Calibrating, Modeling the Measurement Process. And so here he's quite explicit. He says, although calibration sometimes involves explanation, calibrating a measurement instrument does not generally require explaining how the instrument works. Right? So think about just a homely example of this, which we'll get back to later. Right? You're trying to figure out if your kitchen scale, right, is accurately measuring weight, right? What you might do is you might say like, okay, well, I've got this, let's just say, I've got this weight here, which I know is exactly 2 ounces, right? I don't know why you have a 2-ounce weight around your kitchen. You guys are weird, but that's your problem. Right? I plop it on the scale, and if the readout is 2, right, good, we've calibrated. You don't know anything about the workings of mass as a result of doing that, right? Everyone sees that, and that's roughly the idea. Of course, things are more complicated in science, and furthermore, note, it's not clear that you understand a whole lot about weight when you do something like that too. And this is going to be something that I think I can use as a wedge to kind of get into this, right? So that's at least the flyover. I'm trying to make the intuition pump that measurement doesn't require explanation and why you might have that thought to begin this. The other thing I want to point out is there's lots of case studies where it looks like we are improving our understanding, or scientists are improving their understanding by getting better measures. And so what I'll do for that is I'll talk you through my case study. This is basically about measuring segregation. So this is mostly from this essay, 1988 paper by Massey and Denton called The Dimensions of Residential Segregation. And let me start by giving you a little bit of the prehistory that led up to this. So this was published in 1988, and you sort of need to keep track of two time periods that preceded it. One is from about the mid-50s to the mid-70s, and the other is from the mid-70s until 1988 or so. The first of those periods, from let's say 55 to about 75, is what Massey and Denton call the Pax Duncana, right? The Peace of the Duncans. Why is this? Well, because in 1955, Otis Dudley Duncan and Beverly Duncan wrote a paper where they introduced what is still now the dominant way of measuring segregation, what's called the dissimilarity index. And it just sort of ruled the roost for 20 years as sort of, the uncontested champ, if I can kind of put it that way. Then, somewhere around the mid-70s, people started saying, look, this doesn't really capture everything we want to capture with segregation. And they started proposing all sorts of different measures of segregation, all sorts of different segregation indices. So when 1988 rolls around, about a decade later, Massey and Denton sort of characterized their task as one of trying to sort of clean up what they call the theoretical and methodological disarray of this proliferation of different measures. We no longer really have a clear sense of how to measure segregation anymore because there's just too many options, right? So that's sort of the backstory behind this, right? And how do they clean up the disarray? They start off by saying, look, we have all these different measures. There's about 20 of them. But they're not all measuring the same aspects or what they call dimensions of segregation. And so they say there's really 5 distinct dimensions of segregation. And I'll give you the names of them now. We actually aren't going to go through a lot of the details of this because I think it would bog down the discussion. But the 5 dimensions that they mention are unevenness, isolation, concentration, centralization, and clustering. And I'm happy to talk about the details of that. We're just going to focus mostly on unevenness and a little bit on isolation for the rest of the talk. The next thing they do is they hypothesize how these 20 different indices that are sort of out there, right, circa 1988, right, each of them maps onto one and exactly one of those 5 dimensions, right? That's their next claim, right? Then what they do is they basically create a data set by calculating the values of each of those 20 indices for 3 different minority groups, right? African Americans, Hispanic Americans, and Asian Americans, in 60 different metropolitan areas, right? So they now have a whole bunch of different measures of segregation that they can start testing things with, right? And essentially what they do is they test the hypothesis that there are 5 dimensions of segregation and that each index measures exactly one of them. And so that's the penultimate step, right? And then finally, what they do is they say, hey, we did pretty good with this, right? We found that the 6 indices that we thought measured unevenness do in fact measure unevenness, ditto with the next 4 dimensions, right? And the next 14 indices. And they say to themselves, now what we want to do is we want to select the best index, right, for each dimension of segregation, right? They themselves sort of characterize this as a gain in understanding, and I think it's fair to say that the subsequent uptake of this particular development by sociologists more broadly and segregation researchers more broadly favors that verdict, right? But hopefully you can already see, like, we were lumping together a bunch of things with segregation. That was a bit of a lack of understanding, and we clarified it by recognizing that there's 5 different things that we're measuring, right? Hopefully you just have an intuition that there's some kind of understanding going on there. Right. Other thing I want you to notice, I did not mention the word explanation once in going through that whole story, right? Okay, so like I said, I'm a big fan of tethering understanding to explanation, right? So this feels like a puzzle for me, right? What I'm going to do now is get you a little bit clearer about how I think about understanding before I start sort of working through Massey and Denton. So a lot of these ideas sort of fleetingly crystallized in 2017 in my book, Understanding, Explanation, and Scientific Knowledge, mostly about natural scientific understanding. I didn't really look a lot at the social sciences. And then more recently in 2023, I sort of revised my views slightly, and I'll use that version in what follows. 2023 has a very clever title as far as I'm concerned, which is, Should Friends and Frenemies of Understanding Be Friends? So that's where I'm pulling a lot of these ideas from. Now, the full-blown version of this has a third condition, which I'm not going to talk about, but it's basically just understanding requires explanation. For present purposes, I only need to use 2 principles, is what I'll call them. The first is what I call the nexus principle, right? So it says, understanding improves in proportion to the amount of correct explanatory information that you possess, right? Let me just give you a toy example to motivate what this is saying, right? So suppose that a house catches fire, right? And Carolyn can identify 2 causes of that fire, and I can only identify one of those causes, right? All else being equal, it looks like Carolyn understands why the fire occurred better than I do, right? That would be the rough idea behind this. I'll unpack a few more terms in this just so we're clear about it, right? Yeah, and I see someone writing down. These are going to do a lot of work, so just sort of keep them in mind in what follows, right? So first, I'm an explanatory pluralist. I basically think there's lots of different ways of explaining a phenomenon. But very roughly, this is what I think. I think if you have one thing explaining another thing, right? Let's call this the thing that's doing the explaining A and the thing that's being explained B. What you have to do is you have to be able to wiggle A and see a corresponding change in B, right? There's lots of other constraints you might need depending on the facts of the particular case, but that's the big one. And there's an accuracy requirement, which I capture with correctness, right? Now, for those of you who know a little bit about the understanding literature, you know that what counts as correct information when you're talking about understanding is hotly contested. So some people are just of the mindset that, like, hey, you can have a completely false model, but as long as it generates the right predictions, that's good enough for understanding. So that would be someone like my friend Henk de Recht, who will make an appearance a little bit later in this talk, right? On the other end of things, you might have people who think you have to have a perfectly accurate model, right, in order to understand things. When you are radically inaccurate about things, you're just misunderstanding things, right? Most of us are somewhere in the middle. In that frenemies paper I mentioned, I end up saying, like, actually, there's a lot of wiggle room here, and very little of it makes a difference, actually, to the understanding literature. So correctness just means choose your favorite standard of accuracy so long as it's reasonable, essentially. Okay, what does it mean to possess that information, right? So as I construe that, it's sort of any number of cognitive attitudes will do, right? So it could be something like believing, right, that A explains B, or it could be accepting for the purposes at hand that A explains B, or endorsing, right, for the purposes of moving inquiry along. Choose pick your poison with that. It doesn't really matter for the points I'm going to make, and often scientific practice is actually rather Catholic or permissive about the particular attitude that you adopt, so long as it's broadly a cognitive attitude. Right, so like the things that aren't going to cut it is like you can't lust after an explanation and understand, right? Like that's the kind of stuff that I just want to rule out. Okay, so problem with that, right? Let's just go back to that for a sec. If all you can do is say like believe a bunch of correct explanations, right, and you just start racking up explanations that way, we feel like that's somehow a deficient account of understanding, right? Here's roughly what I think we feel is lacking in that case, right? People need to be able to do cool stuff, right, with that explanatory information in order to understand things. They need to use it in a sort of skillful way or exhibit certain kinds of cognitive abilities with that explanatory information to make it happen. So when we think about science, we think about how scientists can hook up an explanation to a larger theoretical framework or draw novel predictions from it or something along those lines, right? And so we need a way of capturing that, and the nexus principle doesn't do that on its own, right? So the standard kinds of cases that worry people are, suppose I just start racking up correct explanations by rote memorization or by passive testimonial uptake, right, from a reliable source, right? The thought is there's something missing from my understanding, right, because I can't do the kinds of things that we think of as what I'm calling cool stuff, right? So that's where the second principle in my account figures in. It's called the scientific knowledge principle, right? So this is the idea that understanding improves in proportion to its resemblance to scientific knowledge of an explanation, right, is roughly the idea. Let's once again sort of have a toy example. This time I'll go back to Dan's understanding of peptic ulcers, right? So both Dan and I know that bacteria cause peptic ulcers, right? But Dan can situate it within a whole rich network of experimental results and theoretical findings about biology and bacteriology. I just have this bare true belief that bacteria causes peptic ulcers, right? It seems like Dan understands better than I do, right? That's what this is supposed to be capturing, right? Now, a crucial part of this is unpacking what I mean by scientific knowledge of an explanation. And so I give a slightly longer story about that, and I'll sort of talk you through bits of that. So one component to this is a safety condition, and this is sort of a term of art in epistemology. But very roughly, a belief is safe if it could not easily have been false given the way in which it was formed, right? Note that this doesn't yet give you cool stuff, right? I can have reliable rote memorization that's safe, right? If I've got a good memory, right? If I passively sort of learn about what causes ulcers from a reliable source. It can be safe, but I'm not doing cool stuff with that information, right? So that's just a necessary condition, but I need a further condition on top of that. And it really has to do with that rider about the kinds of belief-forming processes that go into this. And so I think there's a widespread kind of belief-forming process in how scientists form explanatory commitments, which I call scientific explanatory evaluation, or SEEing for short. So basically what I've tried to do with this is capture what I think are some core features of the ways in which scientists come to accept explanatory hypotheses. And SEEing consists of 3 stages, right? SEEing has 3 C's if it helps you. Consideration, comparison, and commitment. And I'll sort of talk you through each of those, right? So when scientists try to figure out what the correct explanation of a phenomenon is, typically what they have to do is they have to start off by considering plausible potential explanations of the phenomenon. So if the phenomenon we're seeking to explain is P, right, then what I'm supposed to be representing here is it could be S that explains P. It could be Q. It could be R, right? And furthermore, you see those dotted lines with question marks. There's relationships between those different explanatory hypotheses that you want to figure out as well. I'm just going to focus on a small number of those relationships, but they can get a lot more complicated. So you see this a lot in science when scientists are choosing a model, right, to test when it's an explanatory hypothesis or an explanatory model. It's also sort of reflected at a finer grain in the variables they choose to put in that model, right? Now, obviously, if you just stopped here, you don't quite understand. You know what could explain P, but you don't know what does explain P, and that's where you need to go next. Well, we'll get there eventually. There's an intermediate step. The next thing you need to do is engage in comparisons, right? There's our second C. And here what you do is you use the best available evidence and methods to figure out which explanation is better than another, right? So in our toy example, we've gathered evidence E1, and that favors Q over S as an explanation of P, and we do the same thing with E2 with respect to Q and R, right? Okay, so you might think to yourself, at this point we do understand, right? Not quite yet, right? So let me give you a couple of scenarios where you might sort of think there's a gap in your understanding, right? Imagine that E1 and E2 aren't all that strong of evidence, right? Or imagine that you think, well, I've considered S, Q, and R, but I bet you there's something else out there that I just haven't thought of, right? At that point, you might think there's a gap in your understanding, and if any of those hunches end up being right, I think there is a gap in your understanding, right? So what you need to do in addition to this is the third stage, which is commitment, right? So in the nice cases, right, the evidence is good and you've considered all the relevant potential explanations, right? And at that point, when things are cooking, right, the winner at the stage of comparison is something that you can take as true or believe, right? And the losers are things that you should take as false or disbelieve. So that's why there's the negation signs in front of S and R, right? If we're continuing with our example, right? And so that's roughly my account of what understanding looks like. Note that because understanding admits of degrees, you can resemble this sort of state to varying degrees, and that will affect how well you understand things, right? Okay, so now we have a view of explanatory understanding in front of ourselves. We're trying to figure out what to do with this measurement stuff, and we're going to use the Massey and Denton case. How am I going to pull this off? Well, it says ×4, but it's going to be ×3 for this. I'm going to show you 4 different ways in which I think measurement improves understanding, and show you that I can make sense of them using either that nexus principle or that scientific knowledge principle. And that's basically what we're going to be doing for the rest of the talk. Oh, and I forgot to hit the timer, but I guess I should be done 1/4 roughly.
Yeah.
Okay. And of course, yeah, I'm going to use my account to make sense of it. Right? Okay. So the first handshake of the 3 that I will discuss today is understanding how possibly, right? And so here's sort of like the big picture way of thinking about it. Measurement involves conceptual work that often enhances understanding, right? Now what I want to do is basically show you the more general argument that I'll be using, and you'll see that this is an instance of like an argumentative strategy that I will repeat many times throughout the rest of the talk, and then I'll give you an illustration using some more details from Massey and Denton, right? Okay, so here's how the argument kind of works. I take a feature of measurement, right? In this case, conceptual work in measurement provides how possibly explanations, right? And note that that has, right, an obvious connection to the X model because there's something about explanations in it, right? Sorry, my model of understanding. Explanation, knowledge, and science, so it's the X model, EKS. Okay, next thing as we note is, hey, I've got something in my wheelhouse to make sense of when understanding improves by way of explanation, right? Remember, the nexus principle says understanding improves when there's more explanatory information, right? So you combine these 2 points, right? And you get basically the handshake that I was talking about, that conceptual work often enhances understanding. So this is going to sort of be an argumentative strategy that I use throughout. You'll see that the premises sort of vary and the conclusions vary, but it's just basically going to always have this kind of flavor to it. Now, the crucial thing for me to unpack here is really that first premise, right? What does it mean for conceptual work in measurement to provide how possibly explanation? So first of all, let me just say a little bit about what I mean by conceptual work in measurement, right? It's really hard to measure something if you don't have something like a systematic concept of what you're trying to measure. Like what are we trying to measure before we even figure out whether we have an accurate measure of something is like an important question to ask, right? Everyone sees that. And once you have that, because you have a clear concept, you start to see different possibilities that get borne out. And when you have when you're doing something like Massey and Denton, where you're sort of saying, look, there was this concept that we were lumping a bunch of things together, right? This one-dimensional kind of notion of segregation when it turns out to be 5 dimensions, there's really neat things you can do with how possibly explanation. So let me talk you through some of that by talking you through 2 of the dimensions, right? So unevenness is one aspect or dimension of segregation, and it's basically the degree to which there are predominantly minority and predominantly majority neighborhoods in a metropolitan area. So in the US, the majority group is typically characterized as non-Hispanic whites. All right, so let me sort of talk you through how to interpret these diagrams I have up here, right? So each big white square on the left and the right are supposed to represent metropolitan areas, right? Each square with 4 circles in it is supposed to be a neighborhood in that metropolitan area, right? Each circle, right, is supposed to be a unit of population, let's say about 2,000 people, right? Then we'll say that the white circles are our majority group, our non-Hispanic whites in the US, and the blue circles will be a particular ethnic or racial minority, right? Now, if you look at these 2 diagrams, and with that in mind, you can see that the metropolitan area on the left, right, is more even than the metropolitan area on the right, right? And hopefully you have an intuition that it's also the one on the right is more segregated than the one on the left. Okay, everyone sees that too? Okay, great. All right, we need one more ingredient before we can get the how possibly explanation in place. Let's introduce a second dimension of segregation that they discuss, isolation, right? The extent to which minorities live in predominantly white neighborhoods or predominantly majority group neighborhoods, right? So let's look at these 2 metro areas, right? Now, if you look at them, they're both even, right? Like evenness is the same on both of them. But hopefully you see that the guy on the guy on the right, there's more isolation there, and hopefully that also feels more segregated, right? So what do we learn from this? We learn how it's possible, right, for one metropolitan area to be more isolated or more segregated along one dimension more generally, while remaining constant along another dimension, right? In this case, we learn how one metropolitan area exhibits more isolation even when evenness is held fixed, right? That's the how possibly explanation we get. Crucially, you can also see what's the mechanism behind that, right? What makes that, what drives that? Well, basically that the minority population is a smaller share, right, of the metro population on the right-hand side than it is on the left-hand side, right? So we've answered a how possibly question, right? We've given ourselves a how possibly explanation. Now, once again, right, just to sort of tie a bow on this, how possibly explanations are explanations, right? We've gained this from thinking about measurement, right? And we now have better understanding that sort of fits an explanatory mold. Right? Okay, so that's very much about understanding segregation. What I want to point out is often what we understand is how to measure segregation, or maybe better put, we understand segregation indices, right? And this is my second handshake, understanding of measurement as opposed to how possibly understanding, right? So basically it says scientists understand how measurement procedures and instruments work, and what I want to suggest is that you can make sense of this using my account of understanding, right? So I'm going to need to give you a little bit of terminology to start things off from the philosophy of measurement. Then what I'll do is I'll give you one argument which basically redeems this using the nexus principle, right? And another one that redeems this using the scientific knowledge principle. And then I'll illustrate it with Massey and Denton. Okay. So one piece of, let's start with indications. Indications are sort of the final state of what are called measurement processes, right? And what measurement processes are is they're the physical interactions that get you from the object that you're trying to measure through the instruments and the environment, and that sort of yields the indication, right? Indications aren't yet sort of saying anything about the world, right? So an indication in this case would be the screen reads 86.4, where you should understand that as an uninterpreted numeral. It's not even a number, right? It's just like sort of scribbles on a page. In this case, they're just sort of lines on an LED screen, right? So contrast that with a measurement outcome, which is what we're really looking for in measurement, right? This is a knowledge claim where you attribute the measured property to an object, right? So the measurement outcome, if everything is going well in this case, would be a claim that the strawberries weigh 86.4 grams, right? So in the first case, all we're saying is the LED indicates, whoops. In the first case, all we're saying is the LED reads 86.4, right? And we're not yet talking about weight or strawberries, right? The measurement outcome does that. Okay, so the big task, if you're trying to sort of calibrate an instrument, is to make sure that your indications are good representations of the measurement outcome, right? That's the goal. And for that, you need what's called a forward calibration function. And I'm taking this once again from Aran Tal, right? So very roughly, in at least tidy cases, we're actually going to look at a slightly messier case, but I'm not going to talk about the mess. In tidy cases, you have a standard of measurement. We talked about this before. So this was like having that 2-pound weight that you then throw on the digital scale. And if it reads 2, well, then you know you've got something good. So the thought is you're going to have an outcome which helps to, where you have that value from some other way of measuring the quantity of interest that you can then use to calibrate the readouts, right, on your scale, right? So I take it everyone has done some crude version of this, maybe with a scale or some other measuring device, right? Okay, yeah, so like sometimes what I do is I cross-check my temperature on my phone with someone nearby if like it seems like it's doing something crazy. Like that would be another very crude form of forward calibration. Okay, what about all those other I1s through INs? Those are supposed to be parameters that capture different aspects of the measurement process, right? So let me just give you a simple example using our kitchen scale again. Imagine that one of the LED lights is burnt out, right, on that readout, right? So then maybe when we get the indication of 86.4, it's actually 88.4 is what we're seeing, right? That would be something you'd have to capture in the calibration function. You'd say like, okay, I now know that the LED bulb's burnt out, so really it could be 188.4 and not 88.4, not 86.4. Those would be very heavy strawberries. Okay, so now we can turn to sort of establishing the handshake, right? So what happens in forward calibration, right? This doesn't always happen, but I think this happens when you actually do understand the measurement process, right? The measurement outcome should be explaining why the indication is what it is, right? So when the strawberry's working out when the scale's working out properly, I know it's the weight of the strawberry that's explaining why 86.4 is flashing on that screen, right? Because the strawberry is 86.4 grams, right? That's supposed to be the idea, right? Now, obviously, right, there's explanatory information to be had there, right? I say, yay, right? Good. The nexus principle says that's a good way of getting understanding, and so the handshake is established, right? Let me give you the second argument. Now I'll use the scientific knowledge principle, right? So you remember this is stuff about considering, comparing, and committing to explanations. Remember we had all those I1 through IN, right? Those are potential explanations of why the readout is what it is, right? If the LED light is burnt out, that might be explaining why you're seeing 86.4, not the fact that the strawberry is 86.4 grams, right? These are the kinds of things you need to consider, and obviously as the measurement process gets more complicated, right, there's more explanations you need to consider and ultimately rule out with careful testing and stuff like that, comparisons and so on and so forth, right? That, of course, right, is part and parcel to the scientific knowledge principle, right, which says basically understanding improves in proportion to scientific knowledge of an explanation. Right, so we have another way of basically seeing, right, in both cases the conclusion is in forward calibration, right, scientists improve their understanding of why a measurement process behaves the way that it does, right, is roughly the idea. Okay, so how does this play out with Massey and Denton? This is a little bit messier, and I'm going to try and sort of fly over some of the more technical details, so hopefully you just get the intuition behind this. So remember I said they sort of created this data set by taking those 20 indices they were looking at, calculating the value for each of them for 3 different groups, right, in 60 different cities. So it's the 50 most populous cities according to the 1980 census, right? because they were publishing in '88. Plus, just to get a better spread of observations, they looked at 10 US cities with high Hispanic populations. Right? So they ended up finding basically, so they say, all right, well, these 6 indices are measures of unevenness. The next 4 are for isolation, et cetera, et cetera, et cetera. And they basically find that those all correlate very highly with each other as hypothesized and don't correlate very highly with the other indices, right? So that's already maybe sort of like a sketch of an explanation. It's like, okay, they seem to be measuring the same thing, right, is basically the conclusion they draw from this. But they go a little bit further, right? And they consider, right, first stage of seeing, right, whether they have actually, whether segregation has the dimensional structure that they suggest, right? So does segregation really have 5 dimensions, right, the 5D in the middle? Or is it fewer than 5, right? Or is it more than 5? Or maybe there's 5, but it's not the 5 that we mentioned, right? It's not unevenness, isolation, et cetera, right? So how do they handle this? They handle this using a statistical method called factor analysis, right? And I'm not going to get into the details of this. Let me just give you a very homely example of this. How many people have taken a survey where 2 of the questions seem like they're just asking the same damn thing, right? Okay, so how do you deal with that? You use a factor analysis. And basically what that says is, hey, we're going to hypothesize that there's a common cause behind this. And if you test for that hypothesis and it works out properly, then you basically know that you're not going to lose any information by using one of the measures alone. So like in this toy example, you could get rid of either measure 1 or measure 2, and you wouldn't lose any information, is roughly the idea. So they conduct a factor analysis on that data set that I described to you with the 60 cities and so on and so forth. And I'll just give you one snippet of this. It gets barbarous really quickly. Here's basically how they're testing their hypothesis about unevenness, and I'll just sort of talk you through what's going on here, right? So on the leftmost column, right, those are the 6 indices that they hypothesized had something that were measures of unevenness. So the first one is D, the dissimilarity index that's associated with the Paxton-Khana that I mentioned before. G is the Gini index. H is an entropy index, and A1 through A9 are what are called Atkinson's indices. They just have a slight tweak in one parameter across the 3 different measures, right? Okay, so now you see that row that says 1, 2, 3, 4, 5. Those are the factors. Those are the hypothesized common causes of things. And what I want you to notice here is how they load, to use the language there, very heavily on factor 1 and don't load very heavily on the other factors, right? Rough idea here, all of them are measuring unevenness and they're not measuring anything else. Exactly what Massey and Denton wanted. Guess what they do with the other 4 factors and the other indices, right? Just rinse, lather, repeat. And the results are not quite as clean as this one. I'll just go ahead and say that. I think that actually is a nice place for understanding to do more work, but I won't get into the details of that here because I don't want you to have to look at too many of these tables. I think that's unkind. Okay. So essentially what we see is they use the factor analysis as a further body of evidence. I probably should have thrown it on this little toy diagram over here. But they end up basically finding that the 5-dimensional account of residential segregation better comports with the factor analysis, the results of the factor analysis, than other dimensional structures, right? And they don't have to actually get into the details of the other residential structures. This kind of has a way of clearing the neighborhood of a lot of things, right? So it looks like they're doing a bit of scientific explanatory evaluation. That seems to be part and parcel to what I consider scientific knowledge of an explanation, which in turn is part and parcel to what I think of as characteristic of understanding, right? Is roughly the idea. Okay, doing all right. Okay, so for the last handshake I'm going to talk about today, and we can talk about the 4th one if you want. It's the least interesting one, which is one of the reasons why I didn't get into it. It's what I like to call calibrating toward understanding, right? So the idea here is that a measure's potential to promote understanding is one of the reasons that we select that measure over other measures, right? So if you remember, the last thing that I mentioned that Massey and Denton do is they choose the best index for each dimension. And what I want to suggest is partly they do this based on the promise of improving explanatory understanding, right? So let's look at the argument, right? Goes as follows. A measure's potential to contribute to seeing partly determines its acceptability, right? Obviously, seeing is part and parcel to my story of understanding, and so we get that a measure's potential to contribute to understanding, right, determines its acceptability, right? So let's go back to our factor analysis over here, right? Now, one thing I want to sort of flag for you is like these are all doing really, really well in measuring unevenness, right? They're all right, loading very heavily on factor 1 and not loading very heavily on the other ones, right? But if you're just to go by the numbers, you might go by A9, right? It looks like it loads the most heavily on factor 1, and it loads really lightly on all the other ones, right? But that's not what they choose. They choose our good friend, the dissimilarity index, right? And they sort of identify two criteria for why they do this, right? So the first is ease of interpretation and calculation. So let me just tell you a little bit about the dissimilarity index, because you'll start to see why it's got this sort of ease of use associated with it. Right? Essentially what the dissimilarity index does is it tells you the percentage of a minority group that has to move from neighborhoods in which they're overrepresented to neighborhoods in which they're underrepresented, such that each neighborhood is sort of a microcosm of the larger metropolitan area of which it's a part with respect to its racial composition. So just to give you a concrete example of this, I think I checked, and about 48% of the Los Angeles metro area is Hispanic, right? So what that would say is basically you're going to have no segregation if every neighborhood in the Los Angeles metropolitan area has a 48% Hispanic population, right? Obviously, it's very far from that, right? The dissimilarity index is somewhere around 60%, just to give you an idea. All right, so that's like a useful heuristic. What you might be thinking is, well, what does this have to do with your account of explanation, Khalifa? This is where the frenemies paper is a good one for me. So one thing I tried to do in that paper is I mentioned my friend Henk de Recht, a really good Dutch philosopher of science who was working on scientific understanding about a decade before I was, because he's older than I am. He really inspired me in a lot of ways. But we've disagreed a lot in print. And I was like, I'm tired of disagreeing. Like, let's sort of figure out how we can piece these things together. So Henk has this really nice criterion, which he calls the criterion of the intelligibility of theories, right? And very roughly, you'll see that it fits really nicely with this, right? A theory is intelligible to the extent that you can draw the characteristic qualitative consequences of the theory without performing exact calculations. He gets this. It's not clear quite where it came up in the history. We think it might be Dirac who first came up with this. Maybe it was Heisenberg. We're not quite sure. But anyway, he does a really great job of walking through basically 200 years of physics and showing that this is a really useful criterion for intelligibility. And ultimately, he too thinks that that's a criterion for whether you have a good explanation, whether it's based on an intelligible theory, right? So Henk's motivation for doing this is he thinks this is the way that scientists can actually construct explanatory models, when it's easy to interpret and easy to calculate. What I say to myself, what I said when I looked at this is, something, I've never said very much about how scientists come to consider the explanations that they do in that first stage of scientific explanatory evaluation. This seems like a really good criterion, so I'm just going to steal it from Henk, and then I say he should steal some things from me, but I won't mention that. But Henk's view is otherwise sterling. So that's roughly the idea, is like this is a really good way of building explanatory models, which then further on down the line have to be compared, and ultimately you have to form the appropriate commitments to them. So this happens with, there's a bunch of interesting cases in relatively recent sociology where it looks like they are actually using something like these heuristics of model construction. I've been looking through this recent book by Fawcett that seems to sort of capture this nicely, but I need to do a little bit more homework on it. The other thing they mention is a principle that's often really dreaded if it's glossed one way. I think this is a version of methodological conservatism, and everyone sort of like runs away from methodological conservatism. Here's a place where I think it's actually quite valuable, and it's that comparability, right, is often seen to be a really important desideratum on measures and on studies more generally. So what's comparability? It's the idea that when this study over here is sort of making an explanatory claim that has some bearing on this study over here, we have a way of comparing apples to apples, right? So now note, if you've had an index that's been in use as much as the dissimilarity index has, right? So for a good 30 years by the time Massey and Denton were writing about it, and continues to be widely used today, right? If I want to sort of like compare my hypotheses to all this work in segregation that's been going on for this time, it's a good idea to use the dissimilarity index, considering that I don't lose very much by using it over any of those other 5 indices that are measuring unevenness, right? This is obviously really important for explanatory comparisons, amongst other things, right? But that's roughly the idea behind this. Okay, and I see that I'm just about out of time, and that's good because I'm approaching my conclusion. But just to sort of tie a bow on this, right? It looks like indices are helping us. Like we choose indices partly on how well they allow us to engage in explanatory evaluation. Once again, right, something that works out really well if you have my account of understanding. Okay, So take-home lessons, right? Measurement interacts with understanding in at least, I think, 4 distinct and hopefully interesting ways, right? Understanding how possibly, which we saw with those different diagrams with isolation and exposure, or sorry, unevenness and exposure. Understanding of measurement, which we used like the strawberry example, but then we talked about the factor analysis. And calibrating toward understanding, which we talked about when they were choosing the best indices using things like ease of use or ease of interpretation and comparability. Right? The fourth one, which I didn't talk about, is understanding from measurement, but it's a really basic idea. When you have good measures of things like segregation, it means that anything that uses segregation either to explain something else or any explanation of segregation is going to be better off on the view. I think it's a fairly straightforward view. And remember, right, this was supposed to be a tough case, right, for explanatory accounts of understanding. Right? I think I've done a decent job. I mean, I haven't nailed the coffin in it, right? There might be other cases of measurement, of understanding through measurement, which somehow bypass this. But I'm at least just trying to get the conversation started, right? And what I want to point out is if, in fact, that initial judgment that explanatory accounts of understanding, right, don't do a great job with measurement, with understanding vis-a-vis measurement, right? I think this is sort of a call to arms for theorists of understanding such as myself, who aren't even maybe committed to explanatory accounts, right? To start seeing how they can bring their resources to bear on the measurement literature. Right? And so that's essentially the last thing I got to say. Thank you very much for your time.
So I guess this all felt kind of like, what would I say, like maybe intuitive to me. Like, I don't know, I felt like, oh, well, of course maybe you need a explanation to be able to say you understand something. So I guess more what I'm curious about is what would like an objection from the other side of the debate look like? Like what kind of is their argument for saying you don't require that? Because I guess maybe that gives me a more, to kind of see what these, where the clash is between these ideas will help me kind of understand the debate.
Yeah, good. I'm going to not use a measurement example because, like I said, this is sort of a frontier for all of us in the understanding literature. So I'll give you some of the example. People's favorite example, I think I told you, is a thought experiment with Galileo, and maybe you guys have heard of this one. So basically, it's his proof that mass and acceleration are independent of each other. So he says, imagine that we tie a lighter weight to a lighter object to a heavier object, and we drop them. Will the object move faster or slower? Well, because there's a lighter object, shouldn't that slow down, right, the heavier object? But because there's a heavier object, because the combined masses are heavier, and so you end up with a contradiction, right? It'll move faster. So people think like that doesn't look like it involves an explanation because all you're doing is sort of a proof by contradiction. And this was the example that I sort of said is like a really nice flashpoint for the methodological differences between people. So I and another philosopher of science, Michael Strevens, have looked at this example. So let me give you the initial lobby. First, there was a philosopher who's since passed away, Peter Lipton, who sort of brought this example. He said, look, this is understanding without explanation. Then Michael Strevens and I, at roughly the same time, sort of thought, well, there's a feeling of understanding there. And what Michael said is, like, I don't really know whether there's explanatory information encoded in that physical intuition or not. He says, if there is, it's genuine understanding. If not, then I'm willing to bite the bullet and say it just feels like understanding. I actually went through and read the part of the dialogue where this happened, and I said, the reason why this intuition is unstable is basically because what Galileo is doing in that point is criticizing the Aristotelian explanation, which assumed that there was a connection between mass and acceleration. And so what I said is, like, there's a bit of explanatory information there, so good for me, right? But there's not quite an explanation there, and that's why it feels like there's a gap in the understanding when it happens, right? So then there's another wave of people who were more on the epistemological side, and they said, okay, Khalifa, you're right about the history, we grant that. But still, it just feels like understanding, right? We think that's enough, right? And that's that sort of more epistemological way of approaching things, right? Like, surely you don't want to say that Galileo, like, failed to advance our understanding of acceleration when he came up with this thought experiment, is roughly the idea. And I want to say, well, yeah, I'm kind of okay saying that because what I care about is how the science works out. Is that and I think I have a story where he does advance our understanding. It's not like full blown. I call it being on the right track to understanding why is basically a count. So those are the kinds of examples. And Peter Lipton has like sort of a steady diet of them. I'm trying to remember all of them. Some of them are less convincing, but here's like another one. Like Lipton thinks that you can't have an explanation if it's just tacit knowledge, and he points out that we often have tacit understanding of causes, for example, right? So like think about when you use your phone, right? You just like pick it up and you're probably not thinking a lot about it, and before you know it, you're like checking the weather or checking your email or what have you. I'm not going to check my email. It's probably just going to be some dean annoying me about something. Right, and so I do that without really thinking like, oh, I have a causal hypothesis here, and like there are cases where I really can't I can't say it. Like think about standard cases of riding your bike or people who have like good maker's knowledge and stuff like that. So he tends to think like, oh, you don't have an explanation in that case because it's not explicit to you. And my view is like, oh, I don't really think that prohibits you from having an explanation. I think that you just have a tacit explanation, and that's not all that strange. Ends up being my view. So that's kind of how the lobbies have gone. And like I said, a lot of it seems to be very intuition driven. And so what I like about the measurement cases is this seems like actually a really good case for people who don't like explanation to be a requirement of understanding. And it seems to work methodologically along the ways that people like myself and Michael Strevens, for example, want the debate to go. And that's why I think this is an interesting case. But thank you. Yeah, no, great question. Yeah, I'm glad I got to hash out the Galileo gate.
Yeah.
So thank you.
I saw you next.
Yeah, so I was kind of curious, what are the type of like explanandum that we're working with here? Because I see in your arguments, I get how there's like an explanation involved in like understanding how the measurement works, what it's measuring, but how does that link up to like actually getting an explanation or an understanding of the sorts of like things that social scientists will want to explain using these measurements?
Okay, good. So I think it's going to be different for the different handshakes. So in the first case, you're explaining a possibility claim, right? Like so how one dimension of segregation can increase while another one stays the same or even decreases. Obviously, that can happen in real life. So that's at least one thing to say. Or you could contrast cities and see something like that too. In the second case, it's going to be like not about, well, they are, of course, things that social scientists are interested in, but to some extent, it's sort of inside baseball, right? It's understanding how these indices work, right? So that's sort of an explanation, but it's a very low-level explanation, but I think that's partly what's interesting about this case. It's like, those aren't the things that theorists of understanding have been thinking about at all, right? But I think that they're actually quite important because if you remember the quote I had from Iran Tal, like one thing I want to say about that, he says like, look, often we can calibrate instruments and we don't have an explanation. And I'm like, exactly, but we also don't understand the measurement process when that happens. And so I think like that's actually a really interesting kind of way of sort of putting yourself in that debate. I should say Iran's paper, once again, I cannot say enough good things about this paper. Like I know that sounded like I was throwing a little bit of shade at him, but I'm not. He goes through that paper and he says there's at least 3 different kinds of calibrations, right? He says there's black box calibration, where basically you just sort of say, here's the standard of measurement. I'm not going to worry about any of those other things like the LED on the scale. And I'm just going to calibrate my instrument based on this standard. So it's a very sort of unreflective trust of the measurement standard. Then there's the one that I sort of showed you, which is called, he calls it white box calibration. So you have a fixed standard, just like you do in the black box case, but you have all these additional aspects of the measurement process that you're throwing into the calibration function, like the LED light. The most general version, right, doesn't even have a measurement standard. It's what he calls coherent calibration. And that's actually what was going on with the factor analysis. I just didn't want to get into all those details. Where there's nothing that like, it's not that Massey and Denton say like, look, everything's got to sort of square with the dissimilarity index, right? They're all on a par, and the factor analysis is sort of the great equalizer, right? So for making sense of those things. So I think that basically if you climb up that scale from black box to white box to coherent, your understanding improves accordingly. And I think there's actually, this is where there is overlap that's just been underappreciated. So lots of people who, I actually, in the paper I'm working on for this, one thing I point out is like, I'm sort of one of the people who's like a little bit more of a, I'm a little bit more guarded in my enthusiasm about coherentism just in general. So I have a paper on the understanding side, I actually have a few places, but the one that I think sort of exemplifies this is called Must Understanding Be Coherent? What I suggest is like, there's a sense in which you're going to get things that walk and talk a lot like coherence. If you buy this sort of seeing thing, you can already see how there's sort of networks kind of popping up from the little diagrams I have. But ultimately, right, it's not a very strong form of coherentism as epistemologists have understood it. You could actually have very, very robust empiricist foundations, and that would be perfectly fine with what I'm doing. And in fact, most coherentist positions now are sort of attenuated. They say like, yes, some of the, sorry, this is getting really deep into the epistemology, and I hope I will spare you guys this. So the extreme version of coherentism say like, the only justification any claim has is basically its relationship to other claims. Nothing has justification independently of that. And I think that's actually a really hard claim to justify. You might say, well, there's lots of claims that work that way, and maybe the most important claims in measurement or in understanding work that way, but at least some claims, right, have versions of this. And I actually do the same thing in the measurement literature in a paper I co-authored with Sandy Goldberg, where what we point out is actually it gets really hard to see how calibration works if there aren't at least some things that have some independent justification to them. I've now forgot your question. Oh, what we're supposed to be explaining. What we're supposed to be explaining. Yes. So let me tie the bow on this. Sorry, I just started geeking out on coherentism and why I'm a slight hater. Okay. So like what's cool is what I point out initially. Like this is another reason to think that the anti-explanationists, right, might have a leg up on the measurement stuff. Both the measurement people and the anti-explanationists have said a lot about how coherence is sort of this essential thing, right? And then I said, but like someone like me is kind of a hater on coherentism, so if I can get this to work out, like once again, this sort of helps you see how this is a good stress test on my view, and I think it does a pretty good job passing it, is my hope, you know. So that's roughly the idea. So the explananda. In the last case that I talked about, calibrating toward understanding, that's open-ended, and it's partly because it's sort of a forward-looking kind of thing. It's like, all right, we're choosing a measure, right? How are we going to choose this? Well, partly in its potential to figure in explanations. We know not which at this particular point. And to some extent, I don't know that the specific phenomena actually matter too much for that. Like, it's not like they're thinking, well, what I'm really interested in is like the persistence of African-American segregation since the civil rights legislation went through, right? Like that's not a specific phenomenon. They just want to kind of explain anything segregation related at all. It's sort of the job of a good measure. So I think there won't be an explanandum in that last case. For the one I didn't talk about, one thing I pointed out, and I think this is a really cool thing that Massey and Denton did, a year after the paper I talked about, I think they're even sort of obliquely referencing it. One of the big questions is, to what extent does African-American segregation differ from other ethnic and racial minorities? And one thing that they're able to do is actually sort of generate a new phenomenon or a new measure, which they call hypersegregation, right? And what they can say is basically, not only do you see a greater degree of segregation for African Americans across a lot of places, but you see it along more dimensions. So hypersegregation is basically where you have a high degree of segregation across 4 of those 5 dimensions. And what they point out is basically in the 1980s, about 23% of the African American population is hypersegregated. And there are no, and I forget, it's like, I'm forgetting how many metropolitan areas, but there are 0 hypersegregated metropolitan areas for, say, Hispanic Americans at that time. Since then, there have been subsequent census data has basically shown that there is Hispanic hypersegregation, but it's still at a it's much more contained than what you see with African American hypersegregation. So that's the kind of thing where the measure is actually giving you new things to explain and new things that you can explain with, which I think is a really interesting kind of phenomenon. Yeah. Thank you.
Any other questions from students before we open it to faculty?
Yes. Does this account of understanding also relate to the criteria of adequacy for gauging the effectiveness of theories?
You mean like effective field theory and stuff like that, or are you just talking about sort of?
Well, like some of the criteria of adequacy are like testability, fruitfulness, conservatism, and simplicity.
Good. Yeah. So in the paper version of this, this is sort of the common. There's a lot of interesting things to say about this. So those are generally thought to be, as you pointed out, properties of theories. Their sort of history is one that's actually often been wedded to explanation. So there's a really large body on inference to the best explanation. So some of the main players in this are Gil Harman, Bill Lycan, Peter Lipton, Paul Thagard, just to name a few. More recently, Ted Poston, I guess. And basically, all of them want to say these are good making features of an explanation, right? I think where those will show up in my account is basically in the stage of comparison. But it might be path dependent to some extent. So Henk de Recht, who I said I stole some ideas from, he spends a lot of time sort of pointing out how these are criteria of intelligibility, right? So how they're sort of maybe not criteria of intelligibility. They make a theory intelligible, right? They're a property of theories that improve the intelligibility of a theory. So if my account is right, the synthesis that I want between my view and Henk's view, that's going to figure in consideration, and it's going to sort of keep on. This is where there's path dependency. It's just going to push all the way through, right? So if the explanation that you considered ended up having great scope and simplicity and so on and so forth, and it wins out in the stage of comparison, right, then the best explanation is going to be simple. But I tend to think that it figures more in the early stages of explanatory evaluation, and it's not like the people who like inference to the best explanation think it figures more in the comparison stage. I actually think it's quite attenuated in what it does there. I tend to be somewhat sympathetic to a view. Let's see, is there a marker? It doesn't matter. Here's a marker. So I think John Norton has a really nice story about the kinds of criteria. Oh, that doesn't work. John Norton has a nice story about this, where he says what happens is we use words like simplicity, for example, but those are surrogates for more specific kinds of inferential rules that we actually use in scientific practice. I tend to be very sympathetic to that view. But it's something I anguish over because I feel like people often read me and think that I don't think much of the theoretical virtues, but I actually think they're useful in all sorts of ways, just maybe not the ways that other people think that they're useful. But thank you.
Jeff?
Well, I think that's really interesting. And talking about my first question. So I'm thinking that, I think I'm going to do this degrees of understanding.
That's right.
And so I'm going to give you a few cases. So imagine the person understands Volvos, right? Machinery mechanics, all who understand Volvos really well. One, they just fix them. Oh yeah, I think, there's a score that must have been, they've done it for so long, they've seen all these weird counterfactual cases, deciding their chestnut tree, whatever, right? They're not in the carburetor. One of them just does it in all these counterfactual situations. Another one does it and can talk about it. And the third one also has a degree in physics and maybe can't do quite the same things, but can fix other things and explain things in terms of the torque or whatever, and physical apparatus.
So they don't all have the same capacity to repair.
Right.
Let me just make sure I've got the cases. First case, they can repair well but not talk about it. Tacit. Right. Second one, they can repair just as well as the first case and talk about it. And in the third case, they can talk about it really well, but they can't repair it.
I think they can also, it's not that without, but my idea is that they understand, they have more of the traditional.
Yeah, they have more of the theoretical understanding.
But is it, could we imagine, do these have different amounts of understanding? I guess the first and second part.
Yeah, I think those are pretty easy to compare.
Okay.
In the second case, I suspect that actually they don't quite understand the same thing as my hunch. It seems like the first two guys could sort of understand why my car keeps stalling, for example, and know why my car keeps on stalling. Whereas I take it the physicist is just going to say well, I know why cars might stall in general. I don't know exactly what's going on with your car because I don't know about the particular ins and outs of this, the Volvo, right, would be my thought. But probably they're going to know a lot more about, say, torque and combustion and things like that, and how that might even figure out in cars more generally would be my thought.
But these are all legitimate forms of understanding.
Yeah,
in principle, they could be equal in amount.
I think it would be the first and the third certainly would be different in amount. I think there's also dimensions going on there, and I think like I said, I'm not sure that actually they understand the same phenomenon once you start fine graining what's going on. I think it's partly what I would be interested in. It depends a lot. If it's a particular, a highly specific feature of the functioning of, let's say, your Volvo. Are you a Volvo driver?
No.
Oh, okay. Okay. What's your commission? So let's just say it's your Volvo for the sake of illustration, right? It seems to me like what we're going to say is this particular Volvo has these particular properties, and it seems to be like the mechanics are much more likely to know what's going on in this case. I mean, there's a sense in which the physicist's knowledge is not tethered to any particular brand of car, would be my hunch. Of course, he might know that we're talking about this particular Volvo, but there might be something very specific about the properties of that Volvo that he actually can't explain, because he just knows how physical objects work in general. So unless he knows exactly what the the root cause of, like, say, the stalling is, it doesn't seem to me he actually will understand that particular phenomenon, right? Be the thought, like he might understand, yeah, like how engines work, and a fortiori he sort of understands how this engine works. But so that's roughly the thought. Now, I think it's interesting. I think there are going to be cases between the first and the second where we just don't care what the guy can say. Like, we just want the damn car fixed, right? And in that case, we might sort of think, like, given the context, they understand the same given what the interests are. I think from, like, sort of more of a God's eye view, we want to say probably that there's an increase in understanding when you have the ability to express things in words. Might be at least one thought, or to communicate your understanding. Why that is the case, I sort of lay out this case, and I say there's sort of a dilemma. Either you think understanding requires something explicit, or you don't, right? And I think if you think that it doesn't require something explicit, then there's probably not a lot of value added from making it explicit. Like, it seems to be something other than what's going on, or explanation, sorry, requires something explicit. If, on the other hand, you think explanations need to be explicit, I think there's actually a fairly plausible case that there's some value in doing that, right? So we often think, like, I mean, anyone who's been a teacher knows this, right? We understand things better when we can actually explain them to other people, for example. And so I think there's a way of trying to capture that. And of course, in mathematically sophisticated science, I mean, I didn't use any math here, but all these indices have, like, very fancy equations associated with them, or not so fancy equations associated with them. But, like, that gives you immense expressive power, which allows you to sort of say things you wouldn't otherwise be able to say, and to some extent to understand things you wouldn't otherwise be able to understand. So I actually think that there's quite a bit to be said for the explicitness myself, but I haven't thought about that in a while, so it's a good thing to keep on thinking about. Thank you.
Harold?
I have a short factual question and a more speculative one. Can you take my speculative one as a follow-up, please?
Okay.
I'm not the big deal, it's better.
Okay.
Okay, great. My short factual question is, I just, some of the, like, graphs and stuff you showed look like segregation indices might be scale dependent. Like, it really look like the size of the boxes matter for whether the indices like pick it up. I can see an argument for it being scale free, like in the United States, Southeast, for African Americans, for example, seems like much more dense population than in California. And so at that scale, you see a little bit of unevenness for that index.
So one of the desires of at least certain dimensions of segregation is that they are scale invariant. And one of the problems with the dissimilarity index is actually that it's not.
Okay.
But then this is actually the cool thing about doing this factor analysis. They actually point out, like, for lots of practical purposes, right? Once you start running it through real cities, it just doesn't matter that much, right? It does just as well as the ones that are scale invariant. So, yeah.
Also, thank you for the talk. You should that's interesting. I was just trying to kind of like a clarificatory question about the setup and the thesis.
Sure.
And then if you want like a follow-up to that, but I'm happy to just...
I don't want anything.
Yeah. So I was just wondering, is the setup that you say something like, you think scientific understanding requires explanation, but, like, measurement doesn't seem like it is or involves explanation, so it can't contribute or be part of or be a scientific understanding?
Oh, okay.
I think, yeah. What's your modus tollens is my modus. All right. So the challenge, as I see it, is measurement clearly does provide understanding in science.
It does.
Yeah, it does. Yet it doesn't look like it involves explanation. So then that's a challenge for my view, because I think understanding requires explanation. So that's what I take to be the initial challenge. But what I say is, like, initial appearances notwithstanding, actually measurement does involve explanation, and that's sort of the punchline. But I'm working on that, so it's good. It's useful for me to know that that didn't come through as clearly as.
Okay, and then maybe just as a plus, so the thesis is that measurement provides understanding.
Explanatory.
Can we try that just in a couple of, like, are there different ways to express that? Like, you used some language before, like, explanatory information. I just kind of care, it seems just, like, kind of interesting that, like, measurement by itself doesn't seem like it's understanding. Or are you saying it is?
All right, so let's distinguish two different ways of talking about measurement. So one is just like, hey, I'm just gonna, like, throw the strawberries on the scale, right? I'm measuring the weight of the strawberries. That I don't think provides much understanding, if any understanding at all would be my sense. But then, like when you're actually developing new measures, like we were with the segregation researchers here, it seems to me like you're getting a better understanding of the phenomenon as a result, right? Like we didn't know prior to Massey and Denton the dimensions of segregation. We didn't know the best ways to measure segregation. We didn't know that all these 20 different indices like mapped on, each of them maps onto one of these 5 dimensions. And like that all seems to me like we're improving our understanding of segregation at that point.
I was just curious because like, it seems like they understand something and so seek to measure, and then they take the stuff, the product of that measure, and work it back into an explanation. Is that what your model did? So like they thought we had this like one measure and it wasn't like doing enough, and they see that there's something wrong with that. They see we need to measure more stuff, and so that they went out looking to do that measuring. It seems like it reflects understanding on their part or expresses understanding. And then they get some information from those like measures, and they come back and they have like numbers and stuff. And they're like, yes, now I can say this thing is not as good or bad. So it seems like there's like understanding reflected in the getting to go to the measure, and then there's an output of the measurement process. You get a product. I don't know if that's it, like something like that. And then they put that back into the measurement. But it still feels to me a little bit like the measurement itself, unless you have the understanding on the one side, or you bring it back into an understanding on the other side. The measurement kind of by itself doesn't really, like that's not understanding. The way to see that is like somebody who didn't understand who didn't measure.
Yeah, I agree. That's where I'm saying it's like putting strawberries on the scale is that kind. But like think about when we're like, we have a new way of measuring something, right? Which is what we often see in the kinds of cases that interest philosophers of science, right? It seems like when we have a new way of measuring something, we have a better understanding of what's going on, at least in some cases. And what I want to say is a lot of those, this is where I want to sort of like throw down the gauntlet when there's explanatory information involved. I don't know if that, I feel like I still haven't scratched the itch.
Yeah, thank you.
All right, yeah. I feel like I still haven't satisfactorily answered your question, so I'll have to think about it more.
We'll do Carolyn's follow-up and then back to you.
You gained it. So, I wanted to follow up on this with how important the consumer might be. So one possibility is that there's something about the consumer their understanding that is making it like gaining understanding. Another possibility that it's like a type of consumer of information that is relevant. And the reason I'm asking is that I feel like something similar used to be happening in animal cognition literature, also in AI literature, so animal cognition, when animals are able to recognize themselves in mirrors, some people are like, oh, they're just all they're doing is they're just like playing around with the mirror. They're not really seeing themselves. Or with like AI, they're like, oh, the LLMs when they're doing transition work, untrained. So sometimes LLMs are like untrained to transition. But they're just kind of looking for fit or something like that with how but they're not really understanding. And so both of those cases, I think people who push those views, they're thinking that there's just like not the right kind of stuff inside of those things, the LLMs and the to do that work and have the information. So I'm wondering if one of the things that's going on is that there has to be someone behind the wheel that's capable of something in order to.
So yeah, you people who work on minds terrify me because I'm pretty much convinced I'm a zombie. Yeah, I tend to be, David Bourget has recently done some work about sort of what grasp is, and he wants to have a phenomenal conception, and I think that's got to be wrong. I mean, just at least for science, like I don't care what your, phenomenal experience is when you understand something in science. So I probably end up being like, I just tend to think like it's something more like sort of knowing your way around inferentially is like sort of which he sort of entertains but thinks is the wrong view, but doesn't have these sorts of examples in mind. I don't know what that ends up doing, but if you think there needs to be some kind of aha feeling, and I think you want something more than that, he talks about in terms of grasping, right? That there's something distinctive about grasping which has to be sort of animating all of this. Well, partly I guess what I want to say is, let's just even grant that grasping is a requirement, right? I want to say at least what you have to grasp has got to have some explanatory information. So I can sort of just like get off, like join forces there. Alternatively, like I tend to be like highly allergic to talking about grasping. My own view is that grasping is just sort of any sort of cognitive state that bears some resemblance to scientific knowledge of an explanation, and how much you have to resemble it is basically context dependent. That works really well, once again, for science. I don't know how it works when we're talking about everyday people. I feel like somehow this isn't what you're, I feel like I'm not maybe scratching your itch either, though. Like, that would be,
Speculative question. I'm
okay.
asking you.
That's yeah, that's sort of my rough view is like I tend to be well, like, yeah, I'm just kind of dead on the inside, so I tend to want to like avoid exotic mental states if I can at all. Ends up being sort of my view. Yeah. How dead am I on the inside? Just wicked dead.
That you don't have a view necessarily about whether AI or if they had a measurement ability, like whether that would aid in
I mean,
them.
my hunch is that we're probably really close to being able to do what Massey and Den did with AI. Like, I mean, we might even be there. You know, I know a little bit more about sort of what's going on with causal discovery and causal inference, and we're really close there too. Do they understand? I think like the problems are like for me where the rubber hits the road are probably like broadly Salarzian kinds of worries. Like I just think that they're not the kinds of things that are sensitive to inferential norms in the right kinds of ways. And so that ends up being my worry, but that's also a worry that sort of, I think, probably reflects, A, the fact that I was raised by a Salarzian, and B, the fact that I think like probably sensitivity to inference is probably a better sort of working concept of whatever a grasp is in science. And once again, this is that methodological split I was talking about before. I don't know like what would happen if you started asking folks like, all right, do you understand? And you don't have the right phenomenal experience, sort of along the lines that Bourget has, for example. Like he might be right about that. That just feels like that's once again that methodological split that I'm trying my best to sort of achieve wide reflective equilibrium, but if something's got to be cast overboard, it's going to be the epistemological side of that. Yeah.
Okay, we only have time for one more question, and Nigel, Professor Hutton hasn't had a chance to ask. So.
Thank you for your time. I wanted to ask questions about the example of segregation.
Okay.
And so as I understand with the Massey and Hilton article, right, they've given us a much more complex way to understand rather than a kind of single way of thinking. So the construct has really more categories.
Yes.
So then I would want to know what is it that you are doing to help us look for segregation as we are information. So that would be one thing to know about that. And then the other is when you say I have a story for this, or you say like another thing that I have a story for it, when you also and so you are using that concept of story and as it relates to this kind of say so I would be interested to know when you have that expression, what do you
I probably didn't even realize I was using the language of stories very often, so that's interesting. Let me start with the first one. So Massey and Denton, there's a sense in which they both, so relative to that Pax Duncana, they certainly complicated things, right? But then there was that 10-year period in between the Pax Duncana and their work where things were actually like too complicated. There was just these 20 indices kicking around and no one knew which one was the best one to use. So there's a sense in which they sort of tamed that. So they sort of, you know, have in some ways a Goldilocks sort of story. But I think you're right that at least in their conceptualization of segregation, they complicated it in a way that no one had before by saying there's 5 dimensions here, not just one thing, segregation. Good. So I think like in terms of, you asked like what's my contribution here, I think it's probably just a much more general sort of story for social scientists, which is I suspect that this sort of situation pops up a lot in the social sciences. And so what I would say is look for more dimensions, look for more ways to measure things, and then try to sort of figure out what's talking to what. So that is something I've thought about a bit. And I mean, even as I was working through this, I was sort of wondering whether hypersegregation is something that I spent a lot of time working on in another project. And I myself have sort of like, it's sort of all a bit arbitrary. So in the following sense, so each of these indices basically can be scaled from 0 to 1. They say you have high segregation on any dimension when it's 0.6 or higher, and you have to get at least 4 of them. All right, so why 0.6, why 4? I don't think they have a good answer to that, right? And so I've started thinking a little bit more about that and trying to figure out like what would be a principled way to do that. And sort of what I want to do is actually sort of, I haven't come up with any, I had some solutions I was playing with a while back and then kind of dropped them because the math got too hard for me. But I'd like to collaborate with people and see if I can sort of capture the intuitions that are going on where maybe those are a little less arbitrary and try and figure out what's going on with that at some point. That's sort of a future research project. The second question was about stories. So what do I mean by this? I'm happy to sort of think about that in explanatory terms if you want to, because like I said, I'm sort of an explanatory pluralist. Like the main thing is, would one element of that story, were it to be different, would another part of the story also change as a result? And I think like that's usually a pretty important part of storytelling, right? Like if I told you stuff and like the outcome was preordained regardless of the warm up, right, or the lead up to the punchline. Now I'm using jokes as my language. You've got me feeling very self-aware about everything I say now.
I think it's great. That's why I wanted to
Good. So I think that's right. I mean, I don't think anything I said here has great narrative force, so I'll just apologize for that in advance. But yeah, I think I probably mean it in a pretty generic way as just an account, but I do think that certainly narratives have explanatory power, at least some of them. Like, I don't know, like I wouldn't want to figure out what the explanatory power of Ulysses is or something like that, but certainly some of them do.
For me, I was thinking, just to go back to the example of segregation, right? In terms of, I mean, things that we did not know, but we did know, all right? We did know it's in the very depth, abounding in the world, but so in the lived realities of those who have experienced the segregation. So I think what's important to know about your work is, right, that there are people who are, that there's something about belief, or that all of that is there available in front of us, that this is something that helps lives. But the idea that one would want to think about it scientifically, to engage in this kind of their work, there's a sense of belief, I think, that's a part of it. So
I think that's right. So like one thing I think where I do think like exactly what you're talking about where this pops up is, remember those little diagrams I had? Like there's just an intuition that some of these metro areas are more segregated than others. And this has actually been an interesting impetus. I haven't looked at this literature very much, but I'm really interested in it. Lots of people are getting interested in this. And so what it's actually done is people are starting to use like our cell phones and GIS data to try and think of new ways of measuring segregation, which is like, it's still not a perfect proxy for, I think, rich lived experience, but it's like giving you what you might call a street level view of what's going on with segregation in a way that like none of these indices do a very good job with. So one of the things that's like sort of a notorious problem with segregation is the operational definition of a neighborhood as a census tract, which is a somewhat like, they try to choose them so they seem like they're sort of like good proxies for neighborhoods, but they're difficult. There's always going to be an arbitrary dividing line. Partly what they don't want to do is change them from census to census, for example. As much they try to be conservative with those things. Just once again because of comparability. So I think like this is a really interesting question when we think about methodological trade-offs, right? Suppose what we say is, well, we want comparability, so we're going to try and keep the census tracts the same from one census to the other, but the lived experience of living in this little geographic region of a metro area is like really different whether you're in this corner or that corner. Like I think that is a real problem with some of these views, these ways of operationalizing census tracts. And so the good social science on segregation I've seen like takes this very seriously and tries to give you some kind of cross-check where you can say like, look, yeah, we use the census tracts, but if you sort of carve things up differently, the result is still stable and robust across a different way of carving up neighborhoods. But that's very costly to do. So that's one of the challenges. But yeah, these are certainly things. This is why I think you can't just be cranking out statistical tests and doing nothing else, even if perhaps this talk suggested that's all that was going on. No, I think Massey and Denton, the book, I think I had a picture of it early on, American Apartheid, is actually very good at balancing these two things. I think that that's got, I think, a much more powerful narrative than anything I can generate. But it's a very impassioned, discussion of segregation in America. And yes, both Massey and I think especially Denton are like, really, really shrewd and clever quantitative sociologists. But they also have this ability to tell a very compelling and powerful narrative. I mean, it doesn't give you everything, but it shows you why you need both of those things, because that book is, I think, the best book on segregation that's been written in recent times. And it wouldn't work if it didn't have both of those elements working in concert with each other. So thank you.
We'll have to end it there. Please.
Well, thank you. Thank you. Appreciate it.